Hello, in this video we are working through example 2 in section 8.5. We are now on day 2 of 8.4, talking about absolute convergence of series. If you recall the theorem that we just saw in the notes said that a series, AK, converges absolutely if the series of absolute values, so we look at the absolute value of every single one of our terms, if that series converges. So now in example 2, we need to determine if the series, the sum from n equals 1 to infinity of negative 1 to the n over x squared, is absolutely convergent. So this means we need to look at the series of absolute values. So in this case, the series of absolute values, let me box that off, is, we look at this sum from n equals 1 to infinity of negative 1 to the n over n squared, and we take the absolute value of each one of the terms. Well, n is positive, n squared is positive, so the absolute value of that is no different. But this numerator, the negative 1 to the n, if we take the absolute value of that, negative 1 to the n just gives us negative 1 or positive 1, so if we take the absolute value of that, it just becomes 1. So this means this series simplifies to the sum from n equals 1 to infinity of 1 over n squared. Now, this is a series of absolute values. This is a series of all positive terms. So in order to determine if it converges or not, we need to think back to our convergence tests that apply to all positive terms. This series in particular is a p series because it's of the form 1 over n to the p, and in this case, p is equal to 2. We know for p series it converges based on whether the p-value is greater than or less than 1. In this case, it's greater than 1, which means that it converges. So since our series of absolute values converges, it means that the original series will converge absolutely. So our final conclusion is that the series, the sum from n equals 1 to infinity of negative 1 to the n over n squared, converges absolutely. And therefore, we are done.